Okay, we are to video number 2. Again, if you guys have any input or anything like that, I'm just going to run over the settings and values that I have found work for me. Others probably have more experiences. You know, their cars work a little bit different, but this will get us all working in the right direction here. So first up, let's take a look at Tuner Studio here. And this is the generic sensor input page. And what I want us to look at is our dome setup. Like I mentioned in the last video, we want to use a direct analog in on the computer, not any of these CAN ADCs that we see here. There's a little bit of a lag in the CAN system, so we want to see directly how fast that is. We're going to use linear, and this is where a lot of us go wrong. Using our 0 to 100 psi sensor, James has it written in the firmware that the dome control is used as kPa. So in order to scale a 0 to 100 psi sensor in kPa, our 0 value needs to be around 15 and the 5-volt value needs to be around 877. I say around because somebody might have these at 13, somebody might have it at 17, and these values may be off. The important thing is now that we see we have 8 or 15 and 877, is let me slide some screens over, is that when we bring up our dome control generic sensor, this needs to read 100 kPa, engine off, key on. And mine reads like 99 to 100. So that value is going to be very, very, very close. And once this reads 100, we know that everything is scaled correctly. So I was going to start in open loop tonight. Let's look over here. Boost control's on. We have the system to run dome control, and we'll be in open loop. Here, we've got a coolant threshold. On my personal car, I won't let any boost happen until the motor's at least 150 degrees. You can change that as you will. And then we have our overboost protection. I'm running anything over 420 kPa is where I cut. And then the hysteresis. So as soon as 420 becomes 410, boost control actually turns back on. But by that point, we've lifted because we've hit our head in the windshield so hard. Anyway, I don't have any overboost switching. Off, off, off. I do use launch target. This is actually in kPa, but since we're in open loop, this value will need to be in kPa on the dome. Because I'm typically in closed loop, I ask for 200 kPa in the manifold. But when we're in open loop, these values will be kPa on the dome. That makes it work. And I've posted several times on how I'm doing scramble boost, but I'm doing it through an analog input, and I'm doing boost by gear. So this is foot throttle. I've got one button that table switches to second gear, so I get 340, and then my scramble becomes 380. So that kind of takes care of that page. Now the dome setup page. Honestly, guys, I have always ran simple mode. I've never tried anything else. I seem to nail targets, so I haven't needed to run anything but simple. The code seems to work great. And you can decide whether you want to empty or fill the wastegates. I've just chosen to empty. Don't have an explanation why on that. I just choose to empty between. This is our test mode. We can turn it on. And then we can target these pressures, and you can watch your dome gauge move up and down, and you can almost set your deadband here. Let's get that over there. So if we're going to target 150, then our dome pressure will come up to 150 here, and you can see where it may overshoot or undershoot, and that may come into regulated pressure. So knowing how much regulator pressure you need, we can talk about that now. I need like 45 psi on top of my wastegate dome. So I'm going to regulate like 50 psi into my system. So that way, if I got 80 pounds and I really only need 45, and the fill solenoid or the fill solenoid opens, it's not going to way overshoot because I have way too much pressure coming in. So if you guys see that, gosh, I only need, 300 kPa or 200 kPa on the dome, don't regulate in, 100 psi and wonder why you're overshooting all the time. So run that back, and that will help dial it in too. So you can change these values here when you're enabled in the test mode, and this will go up and down, and you can change your dead zone. You can change this and watch. If we shoot for 150 as a target, and Megasquirt gets you 150, you'll watch the system drop by 12, and then it will shoot you back up to 150. So that's kind of an area where no boost control is being done, so that you're not getting cycles out of the system. I know it seems like a lot on the bench, but in the car you guys won't really notice it. And then here, we have lots of options as far as outputs. I shouldn't say a lot. We have PWM outputs, 2, 3, and some high currents, and then some injector stuff. I like to stick with the high currents. Again, like I talked about in the other video, the high current output is more of an open, close 100%. So we'll get more of a desired output, where a PWM driver is more like an idle driver, where it kind of floats the valve in the middle. So if we can, let's try to use the high current outputs. And then here, you just need to tell it where to find your pressure sensor. So that takes care of that page for what I do. So now here's our boost target, but remember, we're in open loop. So this is targeting dome pressure. So since we're in kPa, 300 kPa is actually 2 bar, right? So we're looking at like 29, let's call it 30 psi on the dome. So I'm asking for 30 psi on the dome to get the desired boost pressure I'm looking for, and 30 psi on the dome may get me, we'd have to look, I don't know, like 320 or 330. Anyway, so we're going to have dome pressure plus our spring pressure. Typically we'll run like a low spring, 4 psi, 10 psi. The lower the spring, the more pressure we run here. So we'll commonly get dome psi plus base psi. So we're getting 30 on the dome, and we've got a 4 psi spring, and then we're generally going to get about 34 pounds. But because we talked earlier in the first video about back pressure, we can look back over here, because we have back pressure pushing up on the valve, and boost pressure coming in. It's a dynamic thing, so you may not get as much boost pressure as you're looking for. So in an open loop, that's something to work with. This table is not directly tied to map pressure. This is solely pressure on top of the dome. So it's good, to get started with this. It's kind of hard to work with one hand here, but I can highlight the whole table, and to get started, a guy might put in 150. Okay. So now our dome pressure, we'll put 150 kPa, which is like 4 or 5 pounds, and then a 4-pound spring gets us 9 pounds of pressure, of manifold pressure. But because we're working with a dynamic system, most of us will find that as RPM increases, back pressure increases. So it's common to actually raise this. So we might actually see this out here, 165, that we might need. We'll scroll all the way across, and then we'll interpolate. So now with that interpolated, we're going to slowly increase the pressure on top of the dome to maintain that 9 psi pressure that we were wanting. yeah, let's close this video down here, and I'll start another one for open loop or for closed loop.